Hi, this is Sung and I'm the Principal and Director of Sky Academy, and up until now we've been doing further trig ratios and we've been looking in particular at the unit circle and the unit circle as a measure of the trig ratios of any angle. Alright, and we've looked at angles that are outside just the normal range of 0 to 90, and we've looked at angles inside the unit circle being 0 to 360, but also 360 and beyond. Okay, negative angles, angles beyond 360, etc. But what I want to do is look at what's happening in each of the four quadrants by putting it all on a graph, right? And we're going to look first of all at y equals to sine theta or sine x, and where the x-axis is your theta axis, going from 0 to 90 to 180 to 270 to 360, etc. And your y-axis really just is the height of the graph. Does that make sense? Because sine theta is really your y-coordinate. Y-coordinate tells you the height, right? So from 0 to 90, we've got our exact values here. Sine theta goes from 0 to a half at 30 degrees, to 1 on root 2 at 45 degrees, root 3 on 2 at 60 degrees, and 1 at 90 degrees. So it starts at 0 here, goes all the way to 1, doesn't go beyond 1, and then from 1 the height drops all the way back down to 180, so it goes to there. So it's going up to 180, so it's going up to 1, and then back to 0 at 180, and then it starts going negative. Do you see that? It goes below the x-axis to minus 1 here. So it goes from 1 to negative 1 at 270 degrees. So at 270 degrees it's going to negative territory, and then back up to 0. But the way it's doing that is from 30 degrees it's going up to half, 45 degrees it's going up to 1 on root 2, and then 60 degrees it's going to root 3 on 2. So it's kind of doing this thing. It's curving up like that. And then it's going from positive back down to 0, doing the opposite thing to 180. Yep. And then it starts going negative, back up and around. So the graph really does look like this. And as it goes past one revolution and does another revolution, it'll keep on doing the wave. It'll go according to that wave, right? So it's called a sine wave or a sine graph, and it looks exactly like that because it follows the height of the y-coordinate as you go around the unit circle as your angle increases. Yes? In terms of the cos graph, what's going on is you're looking at the horizontal displacement because cos is equal to 1. So instead of looking at the graph going up and down like this, we're actually looking at it side on, going what's happening, looking at it side on, so it's almost like this graph is going this way and following the graph going this way as theta goes around in a circle. Because what we're doing is we're measuring how far across to the left or to the right the graph is going, because cos theta is equal to the horizontal displacement x. So we start off with theta equaling 0, measuring 1 on our x. So it starts off at 1, goes to 0 here at 90 degrees, goes to 0, then goes to negative 1 here, and then goes back to 0 at 270, and goes up to 360. At 360 degrees goes back to 1. So what you're doing is you're going from 1 down to 90, but following this pattern here, 1 to 0, following that pattern, which is root 3 here, 1 on root 2 there, whoops, At 60 degrees, it's 30 degrees. So it's following this pattern there, going back down to -1, going back round to 0. Whoops, let me just draw that properly. In a wave fashion, and then going back up to +1, like that. And it will follow that particular pattern. And notice that the graph is very similar to the sine graph if you were to continue the wave ad infinitum. Okay? So the only difference is that this graph is shifted slightly towards the left or to the right. Does that make sense? Alright. Now, let's have a look at what's happening with the tan graphs. With the tan graphs, what's really going on is that tan is equal to sine divided by cos. Right? Tan is equal to sine divided by cos. Now, what's going on here is that when cos is equal to 0, you can't actually divide sine by 0. So at 90 degrees, what's going to happen is you will have what's known as an asymptote. In other words, the graph won't exist at that point. Again, at 270, you're dividing by cos, which is 0. And so there, the graph won't exist at all either. At 180 degrees, the graph would be equal to 0 for sine. So sine over cos, sine would be equal to 0. So in other words, the graph would be equal to 0 at that point. At 0, sine is equal to 0 as well. So it passes through that point. And at 360, you're also equaling to 0. Now what is interesting at this point is here you've got positive divided by positive. So you've got a positive thing happening between 0 and 90. You start at 0 and you go towards infinity in a positive fashion. So it's kind of going to go up like that, right? Between 90 and 180, what's going to happen is it's going to go from negative infinity somewhere, right? But you've got a positive number divided by a negative number, which gives you another negative, and it approaches 0, or it reaches 0 through that negative phase. Yep. What happens from 180 to 270 is you've got a negative divided by a negative. So in this case, you're going positive again, and it's going towards positive infinity. And then in the last phase, you've got a negative number divided by a positive number, which is a negative phase that's happening here. And so you've kind of got this, this graph, which when you kind of do it, it's kind of going to look like a series of graphs that look like that, each with its asymptote going down. Okay, so it kind of looks like a series of like cubic, almost cubic in nature, but they're not cubic, they're tan graphs. Alright? So if you want to have a look, and let's summarize what a sine, cos and tan graph looks like. A sine graph will reach a point, a highest point of 1 and a lowest point of -1, and it will look like a wave that goes through a positive phase and then a negative phase between 0 and 180 to 360. It'll be the negative phase. And then also for a cos graph, it'll be shifted somewhat. It'll go from a positive, from its highest point at 0 all the way through to 0 at 90 degrees, all the way through to its lowest point, which is -1 at 180 degrees, back up to 1 again through 270 degrees, which is 0. And then the tan graphs would be a series of cubic-like curves, but they're not cubic, with asymptotes at 90 degrees and 270 degrees, and passing through 0 at 0, 180 and 360, every multiple of 180 degrees. Yep. So let's just take that all in. I know that that was a lot of information, but if you take that all in, then in the next episode, you know, we can continue on with our exploration of trigonometric functions, but this will come in particularly handy when we start doing more complex trigonometric functions. Thank you very much for watching.